Hi everyone, this is Professor Saida Falafini from Cal Poly Pomona. In this video, I will talk about an example related to decision tree. This example is related to Kroft food products. So this company aims to market a new salad dressing. And from the previous experiences that they have, they know that if they go ahead and market this product nationally, there is only 50% chance that they see success and there is 50% chance that they see a national failure. If they market this product nationally and they see national success, they expect to observe a profit of $1.6 million. However, if they see a national failure, they expect to see a loss of $700,000. Alternatively, they can do a market test, and based on the result of the market test, they can go ahead and market the product nationally or not. If they do a market test, they have to pay $150,000 for this test. And from the past experiences, usually market tests leads to 60% chance of success. If they do a market test and they see positive results, they expect that the chance of national success to increase to 80%. If they do a market test and they see negative results, they expect that the chance of national success goes down to 30%. So given this problem statement, they want to know what is the best decision that they have to go with, and they want to also know the expected value of sample information. Here I have put a summary of the problem statement as we just talked about it. The first decision that this company is facing is, should they go ahead and do a market test or they should not do a market test? If they do a market test, they would see two possible outcomes, either positive results or negative results. The market test leads to positive results with the chance of 60% and negative results with the chance of 40%. If they do a market test and see positive results, they still have to make a decision. Should they go ahead and market this product nationally or not? So then the next decision they have in front of them is that should they go ahead and market the product nationally or do not market the nationally? Also, if they see negative results for the market test, they still have to make that decision. Should we go ahead and market the product nationally or not? Let's assume they do the market test, they see positive results for the market test, and then they decide to go ahead and market the product nationally. What happens next? Then they can either see a national success with the chance of 80% or a national failure with the chance of 20%. Just note that I get the value of all these probabilities from the problem statement. If you remember from the problem statement, we saw that if market test is positive, the chance of national success will increase to 80%. And that's why the probability of national success here is 80% if they already have seen a positive results for the market test. So the same here, if we market the product nationally here, we can observe two possible outcomes. We can either observe a national success or a national failure with a chance of 30% and 70%. And again, these probabilities were obtained from problem statement. If the market test result is negative, the chance of national success will go down to 30%, and that's the value that we see here. Let's look at this decision. If they decide not to test the market, they still have to decide, should they go ahead and market the product nationally or not? If they market the product nationally, they may observe one of these outcomes. They may observe a national success with a chance of 50% or a national failure with a chance of 50%. That's the structure of the decision tree, and we want to know which set of these decisions are the best one to go with. After developing the structure of the decision tree, the next step is to find the monetary value associated with each one of these terminal branches. So let's see what is the monetary value associated with the first terminal branch. So in this branch, what is the situation? They have done a market test and they have seen positive results. Then they have decided to go ahead and market the product nationally and they have seen national success. So what is the monetary value of this terminal branch? Since they already have done a market test and the market test costs $150,000, they have $150,000 negative, that's the cost. But since they have done the national marketing and they have observed national success, they expect to see $1.6 million in profit. So that's plus $1.6 million, which leads to $1.45 million as the value at the end. How about this terminal branch? In this one, they already have done the market test and they have seen the positive results for market tests. They have done the national marketing and they have seen national failure. We again observe the $150,000 as cost for the local test, and we also see another $700,000 in terms of loss because they have observed a national failure. So $0.7 million is equivalent to $700,000. That would lead to losing $850,000. How about this terminal branch? For this scenario, they have done the market test, but they have decided not to go ahead with the national marketing, so they only pay the cost of the market test. And the value for the 3 other branches is similar to the ones that we saw on the top. I strongly recommend you guys to pause the video and calculate the value of these terminal branches to make sure that you also get the same values as I have put in this decision tree. Okay, how about these other 3 terminal branches? So let's look at this terminal branch. For this one, they have not done any market test, but they have done the national marketing and they have seen the national success. So there is no initial cost, and the only thing that they observe is $1.6 million as a profit related to the national success. For this one, they haven't done any market tests, and all they have seen is a national failure, and that leads to losing $700,000. And for this last terminal branch, they have not done any market test, they have not done any national marketing, so all they observe is 0 cost at this stage. So after developing the structure of the decision tree and finding the monetary value associated with terminal branches, the next step is to calculate the monetary value of all the decision branches that we have in this tree and do the cost calculation from right to left to finally find the best set of decisions that we have to take. To do so, I assign the values of 1, 2, 3, and 4 to these events nodes so that we know which one of them we are talking to during this presentation. My goal is to find the monetary value associated with each one of the decisions that this person has to take. Okay, so what is the monetary value associated with this decision? If we take this decision, 2 possible outcomes would happen, each one of them with its own specific probability. So to be able to calculate the monetary value associated with this decision, I have to calculate the expected value associated with 2 outcomes that will come out of that decision. Okay, so that's what we are going for node 1, 2, and 3. For node 1, there are 2 possible outcomes. One leads to $1.45 million as profit. The other one leads to $850,000 as loss. So what is the expected value of associated with node 1? So multiply the profit by its corresponding probability plus multiply this loss by its corresponding probability, and the result is $990,000. We do similar calculations for node 2 and 3, and you can see the corresponding results. Again, I strongly recommend that you pause the video and do the calculations for node 2 and 3 and make sure you get similar numbers as the one I have put in the presentation. So I'm going to go back to the decision tree and I'm going to put the monetary values associated with node 1, 2, 3 on the decision tree. So now that I know the value of both these decisions, market nationally and do not market nationally, the question is that what is the best decision to make if I'm ever at this decision making point? So obviously, if at this point marketing nationally is the best decision to go with, so the value of this decision node will be $990,000. Okay. Similarly, now that we know the value associated with these two decisions, the question is that which one is the best decision if we are ever at this decision making node. If we market nationally, we lose $160,000, but if we do not market nationally, we lose only $150,000. So the better decision is to not market nationally. And similarly here, now that we know the value of these two decisions, we can find what is the best decision if we are ever at this decision making node. So comparing $450,000 for marketing the product nationally against $0 for the profit, if we do not market nationally, we go with marketing the product nationally, and the value of this decision making node will be $450,000. So we are going to continue with our backward calculations of cost. So the next thing is to find the value of this decision and this decision. So we know the value of do not testing the market is $450,000, but what is the value of testing the market? So for that, we have to calculate the value of this event node. To do so, we are going to continue with calculating the value of the event node for two possible outcomes. First one with the value of $990,000, the second one with the loss of $150,000, and we are going to see what is the expected value of event node 4. So we are going to do the corresponding calculations, multiply the values of each one of these branches by the corresponding probabilities, and the final value is $534,000. We put the corresponding value up top of the event node 4. Now we can decide that if we are ever at this decision making node, should we test the market or do not test the market. Comparing the value of associated with these two decisions, comparing the value associated with these two branches, the best decision would be test the market, and we expect the total value of $534,000. And now we are going to calculate expected value of sample information. So if you remember, for calculating the expected value of sample information, we always calculate the value of the decision if we do the market test, but we are not paying anything for the market test. That's why I added $150,000 here, because the total would be the value of doing the market test but not paying anything for the market test. And then I deduct the value of the decision in which we are not doing any market test, and the results is $234,000. What does this value mean? It means if they charge us any value less than $234,000 for the market test, it is better to do the market test. We would benefit from the value of the information that we get from the market test. And as you saw here, since the value that we charged here for the market test was $150,000, we decided to go with the decision in which we did the market test. This is the end of this example.